Hello again, physics. Here we are starting experiment 5 on voltages and circuits. And this time we're looking at the voltages in circuits, whereas the last one we were looking at the resistance. But we've got to pay attention to the resistance as well. So our instructions tell us to get the 3 equal resistors we used in experiment 4, which we've got set up here, using springs to hold them. We're going to connect the wires to the D-cell batteries. So we pay attention to the negative and positive. Now we're going to use the multimeter to measure the voltages across individual resistors and then across combinations of resistors. So to do that, we're going to see how, if I can try to get it all on the screen so you can all see it. So our first resistor, as it was before, now my hand's in the way. $329. Next one, 328. And the next one, also 328. So all around 330. Then it asks us to test from resistance 1 to 2. So we get 658. And across here, 2 to 3, 657. So you can see these two added together to make this one, these two added together to make that one. And so we get one more on here, and then we got all the way across from 1 to 3, and we get 987. And that's all 3 of these added up to make that. Now it wants us to find the voltage across here. So we're going to switch our multimeter to volts, and we're going to be 0 to 20. And to do that, I'm going to have to hook up the battery to the circuit. So we're actually going to have electricity going through the circuit. And we're going to measure the voltage drop across the first resistor. And it is 0.46. The second resistor, 0.46. And the third resistor, interesting. Why would you expect the voltage to be the same across each? Because kind of like a waterfall, the water drops. If they're all the waterfalls the same height, we're going to lose the same amount of elevation on each one. Now, going from 1 to 2, 0.93, what you see is these two numbers basically added together. Should be around 92, but that's close. And then this one also is 0.93. Again, that's these two added together. And then all the way across is 140. Come on. 1.4, I should say. And that's adding all of these up together in the series. All right, that concludes the first side. Let's get on to the next side. So number 5 asks us to set up our resistors in parallel, and so that's what we've done here. We've put them all in parallel, and we've got them connected to the battery. And the first thing it tells us is to write down all the resistors. Well, we already measured the individual resistors, but now we need to measure the resistance in parallel. So let's measure that. I could measure from here to here. I could measure from here to here, or here to here. It's all the same. Notice that it is only 109. because you would have to add 1 over 329 plus 1 over 328 plus 1 over 328 to find out our total. So when you have resistors in parallel, the overall resistance goes down. All right, what about the voltage? Well, we're going to change it over to here. I'm going to connect, the battery's already connected over here. I'm going to finish this circuit by connecting it over here. And let's see what it says the voltage is. Whoops, bumped the camera. See what the voltage is across this one. Oh, 1.39. All right, 1.39 volts. Over here, 1.39. And across here, 1.39. And really, no matter where I put it, it's really doing the same thing. But let's go across here, like maybe I'm somehow doing 1 to 3, and you'll see it is also 1.39. Now, if I had measured the voltage separately and disconnected these, then the voltage would still also be 139. So it's always going to be 1.39 volts for each of these. Okay, because the voltage has to drop from the top all the way to the bottom as it returns back to the battery. We always lose all the voltage. All right, I'll set up for number 4. All right, for number 4, which I think I might have said earlier that was number 5, that was probably number 3. I might have said number 5. So number 4, we are going to connect the circuit below in parallel and series. So here's our single resistor. This is what I put right here. So the electricity is going to come here, go through the first resistor, come to this point, and then split 2 directions. One going this way, and one going to that resistor. They're going to come back together with this red wire, and go on to this. This wire here is represented by this one, and he's going to go on back to the circuit. So first I'm just going to measure the resistance of each one. So the resistance of R1 whoops. Surprise, surprise, still 328 ohms. And then we're going to find the resistance across the 2 resistors. It's 1.65. Notice it doesn't matter where I do it, it's the same. So we'll go 1.64 ohms. And the resistance across all 3 resistors from the first one to the last one is 493. 493, which you'll notice is this number. That's not a 1.64, it's 164. This number plus this number is that number. So now we're going to check the voltage. So I'm going to connect the battery to the circuit and switch the multimeter to volts. And we're going to find the voltage across the first resistor. And this one is 0.93 volts. Across 2 and 3, that's across these 2 guys here, the voltage drop is 0.46. And these 2 numbers together should equal voltage drop across here, which is 140, or 1.40. So 6 and 3 are 9, 9 and 4 are 13. So 139 is if we were to add this all up. And we can see that that is true. So the total voltage in the circuit is about 1.4. All right, on to the next thing. For our circuit for number 5, we're going to use the unequal resistors that we used in experiment 4 to make a series circuit. And then we're going to measure the voltages, the resistances, and then we're going to find the voltages going across those. So just to get it on the screen, I'm going to cover up the circuit with the resistors here. Get the multimeter and test our resistors. The first one is about 10.5. And the next one, 22.4. And the third one, 15.2. Okay, what's the resistance across from A to B? Should be added. Should be 32.5. So that's these two numbers roughly added, and then these two is 37.3. That is these two guys added, and then all the way across, 47.4. That's all three of these added, make up that number. So now let's check what the voltage is across. So to do that, I need to connect the battery to the circuit. All right. Remember to change the multimeter to volts. And let's see. From across A, the voltage is 0.29. From across B is 0.64. We would expect that because bigger resistance should have a bigger drop in voltage. In fact, that resistor is about twice as big as that one, so notice we get about twice the voltage drop. And then across C is 0.43. Whoops, did I say that wrong? No, that's right. 0.43 volts. So these all together should add up to what we get down here. Let's find out. First of all, across A and B, our voltage is 0.94, which is these two numbers added together. B to C, 1.07. That is these two added together. So 60 plus 40 is 107. And then all the way across, we should have the entire battery's voltage drop. And we're at 1.37. The battery's slowly losing voltage. We're using the electricity. So that's why I'm going to disconnect it. You can't see any electricity going, but electricity is going through nonetheless. All right, let's set up for the last little bit here. All right, the bottom of the page that started with number 5 asks us to put the same resistors in parallel, and we're going to see what the resistance is across each, and then compare the voltage here. Now, in parallel, it's really kind of silly to compare differently. So it's 4.9. And since those wires connect, it's the same resistance to here, 4.9. And here should be, we'll go with 4.9 there too as it bounced back and forth. It's basically the same. All right, so when we say across all of them, well, that's what we've been doing. So I'm going to pretend like I'm doing it somehow differently, but you'll see we get the exact same results going all the way across. It's still the same within the accuracy we're measuring. So to do the voltage, we're going to have to connect the battery. So I'm going to sneak this down a little bit so you can try to see that. All right, so we'll put the battery connected here. And now we're going to change our multimeter to volts and measure across A, the voltage drop. Interesting, okay. So either our battery's going dead or something's funny, but we're getting the same number here, about 125. And all right, so as I was measuring, decided that the resistance of the wire, since these resistors are such low resistance, the resistance within the wires was making up a little bit of our error. So I hooked them up to go to the center, so to reduce the amount of wires they have to go through. But here we've got a resistance of 125. Here we have a resistance of 126. And here we have a resistance of 119. In principle, they should be all the same. But you see, each of these had to go through another wire, and yet another wire here, which would increase the resistance, which make the voltage drop a little bit different. But what would be it across the whole thing? Well, if I compare, say, to this side, I get 120. From this side to this side, 124. So it still comes out to be around the same number. With such low voltage resistors, with such low resistance in the resistors, the wires are probably messing us up a little bit. All right, let's flip the page over. For the last part of our lab, on the back page, page 18, where we're setting up our circuit with a series in parallel with, in two resistors in parallel, and yet series with the other resistor, resistor A. So resistor A was our, let's just double check that, that's 10.6, I should put this here, 10.6, and now it's showing 10.5, that's fine, 10.5 ohms. And now we're going to compare B and C across there, and we have 9.5. Because, again, with two resistors, the combined resistance is less than either one of them. And all the way across from A to B, I guess you can't see that too well. From A to B is 19.9. That's this number plus this number makes that number. Now let's check the voltage. To do that, I have to connect the battery. So here we're going to connect the battery to this system, change the multimeter to volts, and check the voltage across A. Voltage drop is 0.71 volts. From across the two in parallel here, we are at 0.64. And together, these should equal what the total is from here to there, 1.36. Okay, so that illustrates how the voltage drop across the whole thing, which this is from battery terminal to battery terminal. That's that number, and then it has to be broken apart. As the voltage goes across the circuit, it has to drop some, and then it drops the rest of the way, and then the entire voltage drop goes from here to there. Now, I want you to do one more thing here at the bottom of your page where you have a little blank space, and we've talked about that all things have resistance. So even these little wires that we've been using have resistance. So I want you to see here that this little white wire, so small white, I'm going to put this on resistor, and let's see just how much resistance is in this little wire alone. So it says it's got a resistance of 0.2. All right, let's put this big white wire on here. and see what its, so we'll go large, white, and see what its resistance is. It says it's also 0.2. So this little red wire is a little thicker, and it's going to be such a small difference we can't tell, but let's put that on there and see what the resistance is for these guys. For this one, also 0.2. So there's these wires have resistance. And so as we did our circuits and so forth, you'll see that there's a little bit of error in the measurements, is what we'd expect, because we can't make these superconductors. So if we were to get really fancy, we'd have to include the resistance of each of these different wires in our circuitry. So that concludes the Circuit 5 lab. Thank you very much. Keep up the good work.